Hi, I'm Dr. Amol Gupta, and I'd like to welcome you to our podcast, COVID Experts, interviews with top physicians and scientists. Through this podcast, we will share the latest clinical and research advancements across the globe to help you better understand the situation with coronavirus and what our future holds. If you have any questions or concerns, please do not hesitate to email us at info@covidexperts.org. Today we are speaking with Dr. Marie Bene. She is a professor of immunology and hematology at the Universitaire Hospital Center in Nantes, France. She has extensively worked on mucosal immunity and recently published a paper in Clinical Infectious Diseases studying the role of immunoglobulins in the host defense against the COVID-19 infection. Let's listen. Dr. Bene, I want to discuss your recent publication titled Good AGA, Bad IgG in SARS-CoV-2 Infection. Can you talk a little bit about this paper?
Okay, I read a paper that was published by Chinese people. The first author is Zhao. They mentioned that they had assessed the antibodies in the plasma or serum of their patients with SARS-CoV-2 infection. They used three different methods. One, assessing all the antibodies that recognize the antigen in the ELISA test that they performed. They also specifically searched IgM, anti-SARS-CoV-2, and IgG. Interestingly, I noticed that the levels of the total antibodies evaluated by binding the antigen were the highest and were present in all the people that tested by day 8. And because there was a difference in the levels of all antibodies, IgM and IgG, I thought that they had also tested for IgA with the antigen test. But they only mentioned that very briefly in the manuscript. And I thought that it might be interesting because very little literature has been coming out about the immune response with antibodies in COVID infection to stress the point that these authors had probably assessed also IgA.
What did you find? You titled the paper Good IgA. So what is the relation of IgA with the SARS-CoV-2 infection?
What I wrote in this paper, this letter actually, is that because SARS-CoV-2 is a respiratory virus, the first response of the body will be secretory IgA, which are produced by the mucosae and which are very good for the protection of everybody against the environment. And probably what these authors found also in the serum was the secondary response that comes after that taking place in the mucosae that gives rise also to IgA and IgM and IgG in the serum. So the conclusion of that first part was that in my mind, it would be very useful to test for the presence of anti-SARS-CoV-2 IgA in the secretions of people. And one very easy way to do that is to test them in the saliva. And that would probably give us a lot of information about the number of people who actually encountered that virus and that probably were asymptomatic because this good IgA protected them. As for the bad IgG, as I mentioned, in some very severe cases, it could be that these pro-inflammatory immunoglobulins can leak through the lung, and by various means that these IgG usually eliminate antigens would be responsible for lung lesions. For instance, they could bind to the virus and make immune complexes that would be phagocytosed by the macrophages, and these activated macrophages could be the source of the IL-6 that gives very bad clinical signs, and also TNF-alpha. Then I came, and another way that this IgG could be bad would be by binding proteins of the virus that is presented at the surface of the infected cells. Once IgG do that, they will activate the complement, and they would also activate NK cells, and that would result in the death of that cell, which is very good because it eliminates cell infected by the virus. But since the lung has an anatomy that is so delicate and fragile, that could be leading to much damage, and especially endothelial damage that we see have been reported in some of the very severe forms of the disease. And finally, I also mentioned another publication where the cytokines had been assayed in the patients, and beside IL-6 and TNF-alpha, they found also IL-10. And IL-10 is an immunosuppressive cytokine. It dampens the immune responses, which is very good in normal physiology because it helps us to stop an immune reaction once it's been doing its job. But in that case, it could be triggering a negative environment by macrophages, which are non-inflammatory, but they also lead to the destruction of the T lymphocytes by expressing PD-L1, which is bound by the activated T cells, which express PD-1. PD-L1 is a ligand of PD-1, and that could result in the death of these lymphocytes at a time when they could still be useful. So the IgG would probably play the role of the bad guy, while in my mind the IgA, and especially the secretory IgA, play the role of the good guy.
This is very interesting. How do you think that your findings can be used in the detection or cure from this virus?
What I believe, but we will know that for sure much later, is that this virus, although it's very noisy in severe cases, basically in most people it's a mild virus. At the beginning of the epidemics, it was talked as a light flu, and I guess that for many people it has been like that. We know that several people are completely asymptomatic. We know that several of us had a bizarre episode of semi-flu at the beginning of the year, and I believe that these people managed themselves to get rid of the virus. In the conclusion of my letter, of our letter, we proposed that we could monitor the epidemics by assessing secretory IgA, anti-COVID, anti-SARS-CoV-2 in the saliva of people. That's non-traumatic. It's very easy to do. There are special little cotton balls that you can chew, and then you spit them in the tube, you centrifuge, and you get the saliva, and then you can get the IgA assessed in that. As for the T cells and the immune complexes, it could be also investigated. It's a bit more complicated, but circulating immune complexes can be assayed in immunology laboratories. And I know and I guess that many immunology laboratories are also working on the T cells specific for SARS-CoV-2, and that they will probably find answers to how, in some people, this response goes wrong.
Are there any investigations going on right now that are utilizing this principle?
I haven't seen anything in the literature, but I haven't done a very exhaustive search about that. Actually, this was the first paper I saw that mentioned IgA, and I found another one after that, and I think that there's been another one last week. I know that a group of immunologists in France actually contacted me because they had this idea of looking for salivary IgA, and they were very happy that we had been proposing this solution or this investigation way.
If the audience today were to take one message from the work you've done as it relates to COVID, what would that message be?
Get your salivary IgA tested for specific salivary IgA anti-SARS-CoV-2. I hope that the test is going to be developed. Basically, tests that are designed or produced at the moment for IgG and IgM can very well be used with IgA. The only thing that you have to do is to use an anti-IgA antibody to reveal the reaction. Guess that this might be getting on in some parts of the world. The reason why these tests have been taking time to come is that SARS-CoV-2 is a coronavirus, which probably shares a lot of antigenic structures with other coronaviruses, and we need to have the right peptide to really assess antibodies that are directed to this specific virus that is creating this havoc on the world.
Now, what relevance does this have to the vaccine development process that right now the whole world is grappling with?
Yes, we need a vaccine, definitely. But as for the ELISA tests, we need a good vaccine with the right antigen that is going to give rise to the protective antibodies and that is going to be specific for SARS-CoV-2. I know that many laboratories are working on that. The news and the media change every day or sometimes 3 times a day with the vaccine is going to be there next week or next year or in 2 years or in 6 months. We don't know. And we don't know at what speed the experiments are done to make sure that the proper antibodies are generated by this vaccine. But we definitely need a vaccine.
What do you think is the main challenge immunologists are facing during the vaccine development?
Finding the right peptide, finding the ones that are going to give rise to the most efficient antibodies. Again, as I said before, I think that the immune response is well controlled in most individuals encountering SARS-CoV-2, and that some people develop severe cases because something is not controlled properly in their immune system. So we perhaps may have to be careful about that, and probably some animal models will be needed before we really decide that we can safely vaccinate everybody.
Wonderful. Thank you so much, Dr. Bene. This was a pleasure talking to you.
Okay, thank you very much. Thank you for noticing our work.
Thank you for listening to COVID Experts. Tune in for more conversations with some great minds on the subject. I'm Dr. Amol Gupta. See you next time.